Hello, this is Mrs. Scarple, and in this video I'm going to walk you through the row reduction process that we can use for solving systems of equations. First thing I want to mention is that this matrix is a representation of the system 2x squared plus 4y equals to 0. The second equation is 3x squared plus 5y equal to -2. So that's why we're able to say that this is a process for solving a system, because the values in the matrix represent the coefficients and the constant in each equation of the system. Now I'm going to just write in the lower corner here that what we want to end up with is a matrix that has a 1 in each column and zeros in the other places. And it's helpful if those 1s are in a diagonal. And the third column, I'm going to put a dashed line here, the third column will be numbers that give us the value for x and for y. So this is where we want to end up with a 1 0 0 1 format in the left two columns of our matrix, and we'll have numbers that could be 1 and 0, but they don't have to be 1 and 0. In fact, they most likely won't be 1 and 0. So we need to have our elimination hats on, the way we think about eliminating things or reducing things as we go through this process. Where I have this 2, I need to turn this position into a 1. There's a couple of ways I could do this. I could divide everything in the first row by 2. That would certainly give me a 1. Or I could subtract the first row from the second row. So 3 subtract 2, 5 subtract 4, -2 subtract 0. That would also work to get a 1 there. And in fact, I think that's what I'm going to do first, is just go ahead and do a subtraction of rows. Now, between each new matrix, I'm going to write what is happening or how I'm getting my new values. So I said I'm going to take row 2, that's the bottom row, subtract the values from row 1, but the result of that is going to go into the row 1 position. So we're going to change the values in row 1 and only row 1, but what we're going to do is take these values in row 2 and subtract row 1 to get our first 1 in our matrix. So that second row is still going to be 3, 5, -2. It's not going to go anywhere, but the values in that first row, that top row, are going to change. So let's do 3 subtract 2 is 1, 5 subtract 4 is 1, -2 subtract 0 is -2. So now the system that's being represented is x plus y equals -2 and 3x plus 5y equals -2. So if you have your elimination hat on, what we're going to be doing next is we've got the 1 we need in our first column. We now need to find that 0 that goes in the first column. So we need to have the x's in this system eliminate in order to get a 0 to place here in this first column. Now I can take and multiply that first equation by 3 and I'll get a 3x. So my system will be 3x plus 3y equals -6, and our bottom equation is still that 3x plus 5y equals -2. Well, I can do a subtraction of row 2 with that multiple of row 1 to get zeros again. And the reason I'm saying take row 2 and subtract row 1 is so that I can keep as many positive numbers as I can for as long as I can. So we're going to take row 2, that 3x plus 5y equal to -2, and we're going to subtract 3 times row 1, and this is going to go into the row 2 position in our matrix. So for now, that first row is going to stay 1, 1, -2. The second row, 3 subtract 3 is 0. 5 subtract 3 is 2. -2 subtract a -6 becomes a +4. I want to put black there. Now when I look at this, I have my first column complete with a 1 and a 0. What I want to do now is get a 1 in the second row, second column. If I look at these numbers, I could do here what I could have done to start with in that first row and just divide everything by 2. So since that's the process, I could also do an elimination process, but I want you to see that we can just take a single row, in this case row 2, and divide everything by the same value to get a 1. So we're going to take row 2 and divide it by 2, because 2 divided by 2 equals 1, and we're going to place our result in the row 2 position. So we will have the 1, 1, -2 yet in our numerator, and our denominator, 0 divided by 2 is 0. 2 divided by 2 is 1. And 4 divided by 2 is 2. I want to put black there again. It's just my way of trying to keep things organized. So now the only thing we have left is to get a 0 in that first row, second column. Well, if I look at the system that this matrix is representing now, I have x plus y equals -2, and then I'm going to have 0x, I'm just going to have the number there, plus 1y equals 2. And in the numerator, that's also a 1x. I shouldn't say numerator, first row is a 1x and a 1y. If I were to subtract my second row from my first row, I would still have a 1, but the y would become 0, which would allow for me to get the value 0 that I need in this matrix. So what I'm going to do, and I'm going to show the description up here, since I'm running out of room over there, I am going to take row 1, subtract row 2, and put the result in row 1. So row 2 is going to stay 0, 1, 2. But to get my first row, I'm going to take and subtract. So 1 subtract 0 is 1. 1 subtract 1 is 0. -2 subtract 2 That is actually a negative 4. So now you can see that I have on the first two columns ones and zeros. You want to have ones follow a diagonal. It just helps keep things organized. And we can now say that our solution is x equals negative 4 and y equals 2. And I need to apologize for something as I'm scanning over my problem here. These shouldn't have been an x squared. They should have just been an x. I apologize for that if that was causing any confusion for you as we moved through this video. And the reason it caught my eye is because I'm going to show you how we can check our answer. We have x, we have y. I can plug them in for x and y in each equation that I wrote there. So I'm just going to make a note that what I'm doing is checking my solution. So x is negative 4, y is 2, so I should be able to check in each of the equations. So I'm going to check in the first one, 2 times negative 4 plus 4 times 2, and what I want to know is, does that equal 0? Well, 2 times negative 4 is negative 8, 4 times 2 is 8, and when I add 8 to negative 8, I do get 0. That's true. So now let's check it in the second equation. Because remember, if it's a solution, it should work in both equations. So 3 times negative 4 plus 5 times 2. What we want to know is, does that equal negative 2? So 3 times negative 4 is negative 12 plus 10 equals negative 2. And negative 12 plus 10 does equal negative 2. That is true. So we have solved this system correctly by doing a row reduction method with matrices. And this concludes this example.